Hi everyone, welcome to Data Labs. I am your dost and host Madhur. Today in this video I will be explaining you some aggregate functions of SQL like counting the number of records, finding minimum and maximum values, doing sum or getting some average values. I will also show you the use and functioning of group by clause in the select statement along with the having clause. Let's begin. I have already created tables employee and department in the database Data Labs demo. Let me quickly show you the data in those tables. Okay, the department table consists of three columns: department ID, department name, and head of department. And the employee table consists of seven columns: employee ID, first name, last name, department ID, age, email, and salary. We will use this data as an example to understand the SQL aggregate functions. The aggregate functions are applied on a column of a table and return us a single result value, like getting total number of records for a table. Today we will cover some basic aggregate functions. Let's begin with the count function. The count function returns us total number of records in a table for the column which we are passing in the count function. The syntax to use count function is putting the function name and then passing the column name in parentheses, as like this. Let's get the record count of employee table. Select from employee, then over here we will pass count and then the column name. So we are going to read all the records for all the columns. So we will just pass star over here for now and read from the table employee. Let's execute this query. This returns us the total number of records as 26. Let's verify that with the query select star from employee. Yes, we have 26 records only. If you see there's no column name mentioned over here, so we can do aliasing over here. So we will name the column as record count from employee. Okay, so the record count is 26. We can also mention any particular column name over here. Select employee ID as record count from employee. Let's fire this query. This will give us again 26 records only. If there was any null in the employee ID, then it would not have included that in the count. Let's see if we have any null value in the table employee. We have a null age over here for employee ID 26. So let's now count age, record count from employee. This should give us total record count as 25 as one is null. Let's see. So we get the record count as 25. We can also mention where conditions over here to get the record count on the basis of some scenarios, on the basis of some conditions. Like let's get the record count for those employees where age is equal to 30. So where age is equal to 30. Let's fire this query, execute. So there are only 5 employees where age is 30. Let's verify this with select star from employee. 1, 2, 3, 4, and 5. So yeah, it gave us the correct result. We can also get a distinct or unique record count, like getting total number of departments in the table employee. Let's see the table employee once again. There are many repeating department IDs in the table employed. 101 is repeating multiple times over here, 102, 103. So to get the total unique department IDs, we will have to fire distinct, then the column name. We'll remove this where clause from here. Let's fire this. This gives us only 4 records as there are only 4 distinct department IDs in the table employee. Let's see this from the table employee itself. How many total distinct department IDs do we have? There are only 4: 101, 102, 103, and 104. We can apply select count star, count column name, then count distinct column name. This was the use and implementation of count function. Now next, let's understand the use and implementation of min and max functions. These functions are used to return minimum and maximum value of a column. The syntax for the function is similar to that of count function, which is function name and then column name in parentheses. But unlike count function, these functions run only on a single column. Let's understand that with an example. Now let's try to get the minimum salary and maximum salary from the table employee. So we will do select min of salary, column name as minimum salary from employee. This is the column name alias and this is the exact column name that we are passing. Let's fire this function, execute. We get the minimum salary as 24,000. To get the maximum salary, we'll have to write a similar function, select max salary, maximum salary from employee. And the maximum salary is 88500. If I try to fire this min or max function on multiple columns like select salary, comma age, this will give us an error. The min function requires only one argument, so we were passing more than one. Now let's get the minimum age as well. So minimum age from employee. Yeah, and over here also we can pass the where condition where department ID is equal to 102. So this will give us the maximum salary when the department ID is 102. Let's execute this query. Execute. The maximum salary is 71,000. We cannot use this count, min or max functions within the where clause. Let's try using it and see what error does it give. Over here we are trying to get the information of all the employees where salary is equal to the max salary. Let's try executing the query. Execute. The aggregate may not appear in the where clause unless it is a subquery contained in a having clause or in a select list. So we got an error over here and we cannot use these aggregate functions within the where clause. Now next, let's understand two other aggregate functions, namely sum and average. The sum function is used to find the sum of the values in a particular column, and AVG function is used to return the average of the values. The syntax for these functions is also same, that is the function name and then the column name in the parentheses, with the only exception that the column name must be some numeric data type, as we cannot do sum or average of a text. Now let's understand these also with examples. Now let's try to find total salary of all the employees in the table employee. So we will fire the query select sum of salary, aliasing as total salary from table employee. Execute. And this is the total salary that we get for all the employees. And if we want to get the average salary, then we put the function as AVG and we get the average salary. So this is the average salary for all the employees. We can do the filtering over here as well, like getting the average salary when the department ID is 102. So we apply this where condition and we execute. Okay, so the average salary for department 102 is 47500. I hope this explains the function and usage of aggregate functions like count, min, max, sum, and average. These are some of the key functions which are used to read the data and do some analysis on that. Now next, let's understand the usage of group by clause in the select query. We'll open a new query. The group by clause is used to get the summary of the data in the tables on the basis of one or multiple columns. We create a group of same data and then apply some aggregate functions on it to get the results on the basis of those groups. The group by clause is used after the from and where clause in the select statement and before order by. The syntax for the group by would be select column names from table name where condition group by column name, and there can be multiple columns over here, and then order by some column name. One thing to remember here is that if we are using the group by clause on certain columns, then we can use only those columns in the select query. Along with that, we can also use some other aggregations as well, but we cannot use any other columns. Now let's understand that with an example. Firstly, let's do a select star from employee. Now let's find the group of employee ages. So we are doing select from employee group by age, and as we are using the column age over here, so we can use only the age column in the select statement. Let's fire this query. This will group by age and will give us all the groups of ages. So we have 27, 28, 29 and so on up to 36 and a null as well. We can do a group by on multiple columns as well. So we can group by department, ID and age. So over here we will be grouping by department ID and age, and we'll be finding same department IDs and same ages. So this will give us that 101 department have these age groups, 102 department have these age groups, 103 have these, and 104 have these. Now if we apply an aggregate function on this, let's firstly apply the aggregate function on a single column. Now let's count the total employee on the basis of the age. So we'll do select age from employee group by age, and over here we will put count of age. Let's see what does this give to us. This is giving us the age and total number of employees which are for that particular age. So this is giving us the age 27 and there is only one employee with age 27. This is giving 28 and there are four employees and so on. 29 have 3, 30 have 5 and so on. You can also put count star, but over here the star would mean all the columns on its left or all the columns which are part of the select query. Now let's do this, execute, and this gives us the same result. If you remember when we were doing the count age, for null we were getting 0, but over here for null we are getting 1. A count on a particular column name eliminates any null values which are there. Now next let's group by department ID and age. So here we will get the employee count for each department for each particular age. Let's execute the query. We have the result with us. So the department ID 104 has age as null and there is only one record with this. We have department ID 101 where age is 27 and there is one record with it. We can also apply a min and max functions over here, like minimum salary for each department and age. Let's find that. So this is giving us the minimum salaries for all these different groups of data. We can also apply more than one aggregate functions over here, as in max salary. Let's execute this query. Okay, so this gives us the minimum and the maximum salary. Let's also do aliasing over here. Now let's fire the query once again. And this is giving us the minimum salary and the maximum salary. And here if you see the minimum salary was 38 and the max salary was 46,500. If I try to put any other column over here, it will give us an error. Let's try putting the column salary itself. Salary column is not part of the group by. Let's execute it. Okay, we got an error over here that the salary column is invalid in the select list because it's not contained in either of the aggregate functions or the group by clause. So the salary column was not part of the group by, but we could apply the aggregations on the salary column over here. So we can apply aggregations, but we cannot use those columns in the select list. Now let's do some more aggregations using group by. Let's find the minimum salary, maximum salary, total salary, and average salary for each department. So we said each department over here, so we'll group by department. So we'll remove age also from here. So we'll find the minimum salary by min salary, maximum salary by max salary, total salary by sum of salaries, and average salary by AVG salary function. Let's fire this query. Okay, so this gives us the aggregated result over here or the summary of the data for departments. That for department ID 101, we had the minimum salary as this, max salary as this, total salary as this, and average salary as this. Now, if you would have noticed, this group by on department ID is giving us only the unique department IDs over here, as it is grouping by on all the department IDs over here. So the result is same as for the distinct of department ID. So the result of the query, select distinct department ID from employee and select department ID from employee, group by department ID will be the same. Let's fire both the queries and see the result. So we get four department IDs over here, 101, 102, 103, and 104. And we'll get the same result over here, 101, 102, 103, and 104. So you can use either of the queries to get the distinct records on the basis of any column. Now let's try to use the where and group by together in a query. Let's fire the same query for all those employees for which the age is greater than or equal to 30. Okay, let's fire this query and we get this result. So there's no issue over here. We are able to use the where and group by together. But if I try to use an aggregate function over here, where age is greater than the average age, now let's see what happens over here. This will give us an error because we can't use an aggregate function over here. But if we want to use any kind of aggregate function in the where clause, then we don't use the where clause, we'll use the having clause with us. So now this query would somewhat look like having age greater than equal to average age. The having clause is also used to filter the data as like the where clause, but the having clause is applied after the group by and only when the group by have been applied. If I don't have any group by used over here and I want to use a having, I can't. Let's try using it. Select star from employee, having department ID equal to 101. Let's see what happens. Execute. See, the column of department ID is invalid in the having clause because it is not contained in either of the aggregate functions or the group by clause. So the having can't be used without the group by, only and only if you have a group by clause, then you can use a having. And one thing to remember over here, we can again use only those columns in the having clause which are being used in the group by and nothing else. So like if over here I wanted to do the having age greater than equal to average age, that would not have been possible. That would have given me an error. Let's try firing this query. This will give me an error because the employee age is invalid in the having clause as it's not the part of group by clause. Now let's fire the query to find the minimum salary, maximum salary, total salary, and average salary for each employee based on department ID, but for only those departments where employee count is greater than 2. So to fire such a query over here, we'll use the same query. To filter on the departments where count is greater than 2, we can't use the where clause as count is the aggregate function and aggregate functions can't be used in the where clause. So we will use the aggregate function in the having clause, having count are greater than 2. Let's fire this query, execute, and we get only three department IDs over here, 101, 102, and 103. We don't get the department ID 104 as the department ID 104 have only two employees. There are only two employees for department ID 104. That's Pawan Singh, employee ID 26, and then the other one is employee ID 2. So whenever we have to use any filter on an aggregate function, we will use the having clause as over here. And this was the usage of group by and having in the select statements. I hope now it should be clear to you that how do we summarize the data using the group by and filter that data using having. So with that, let's wrap up with this session. Please like the video and subscribe the channel. That keeps us motivated to create more such content for you. Also give your feedback or comments in the comment section. You can also let me know if you want me to cover some topics. You can go through the SQL Beginners playlist to know more about SQL concepts. The link to it is there in the description below. See you next time.